This is the motor and speed control off of my printing press. I don't know if it works. I'm assuming it does, but I'll be checking that out before I power things up. This is the original equipment that came with the press. I don't know if it's original. There's some date stamp stuff here from 1951, and the press was made in 1939, but as original as I care. This is it's a Star Kimball motor with a Kimball electric speed controller, which some people call it a rheostat. The schematics call it a transformer. It looks like it's kind of an earlier kind of variac kind of design. This switching between the different windings, and this is the original Cutler hammer start stop switch, so all that needs to be connected together. You see I've put a ultra modern watertight conduit stub on there for this stuff, which I will eventually be using to connect some of this together, along with some armored cable I've got here, and there's some more crammed over on the other side of the garage. Some 4-wire stuff. I'm just going to use this to get the 240 from the other side of my garage to here to hook all this up. So to start out, I'm going to open up this switch and see what's inside. So I'll take this off the bottom. Not sure how I'm going to mount it yet. That was one idea. Open up this. So the knob comes off, I think. And then the front just, there we go. Give you a look inside. Here's a closer view of the inside of this thing. Dr. Frankenstein would be proud. So I was pretty certain that you can just see off the edge here that the motor is wired for 240 or 220 as it was, because there were two leads were taped together or connected together and taped off, which is a good sign that that's wired for 220. And then looking inside here, you can see this little jumper right there that says it's wired for 220 volts. This is very Frankenstein. I like that, here's the knob, put that on there, screw that thing on. You'll notice this screw connects to all this stuff, which has got this copper braided wire attached directly to it, which is the contact that moves around these screws. So that means when this knob is suitably attached, like, why am I not lining this thing up? This seems so easy. Did I have it turned wrong? No, that's right. There we go. Let's fire a screw into that thing. Yeah, that means that when this thing is energized, the moving contact would be energized, which means this wire would be energized. Which means the screw in the middle of this knob would be energized. So if you want a shock, you can just walk up to it and stick your finger in there. So I might have to make a little wooden plug for that or something. Not because I'm overly concerned about safety, but because I'm overly concerned about clumsiness. So yeah, that seems to work. This is a nice, it looks like a slate backed kind of ye olde control panel thing. It'd be really, I don't know, neat to put a clear front on this, but I haven't got time for that. Why I'm inside here is, can't see them. There's brought you in even closer. These 4 screws here. And then somewhere I have a schematic for this, a wiring diagram. Or I don't. I'll have to retrieve yet another copy from inside the house. But I need to get those. I need to get it, the 2 screw terminals on the motor. Oh, while I'm in here, you can see that lovely way this thing kind of jumps along this track and slams down on the contacts. All very nice and rugged. Okay, I'm gonna go get some wire set up or something. Alright, so I was thinking of just hanging a bit of a lead off of this to get to my workbench, so I had something to test with. I've got room in the panel, but I don't have any spare breakers. And that one runs my bandsaw, and I like my bandsaw, so I'm going to leave that alone. And, or maybe not, I don't know. I'm considering plan B. So here's what plan B might look like. That's the bandsaw outlet I was talking about. That's a 240 volt 15 amp outlet for one of these odd looking ducts. I think I might have another one of these kicking around, and if not, I have a plan. But the problem is, this is a good 8 feet from my bench, and I don't have 8 feet of this stuff because I'm cheap. So I think plan's coming together. This will reach my workbench, but I'll plug it into there, which means finding my other one of these. Oh boy. This is my terrifying drawer of electrical doodads. Some meters and stuff in here. A little bit of SJOOW, but not very much. But I might need that, so I think that's rated for 300 volts, something like that. Sure, what the heck. Close enough. Little bits of other stuff I've saved. These look like old power cords. This is... That doesn't feel right. Yeah, that goes in the garbage. Tape. A bunch of conduit fittings. People tell me I'm disorganized. Oh, well that's just 20 amp, 250 volt, 3 phase. Great. Just what I need. What else is in here? Oh, that worked out nicely, so we'll just neatly place these items. Oh, sorry, routed backward. Back into the drawer, just like that. I can't tell. Oop. Okay, we'll go with that. So as luck would have it, I do have some SJOOW. I'm sure electricians say that differently. This is nicely chewed through by probably me. But it has a 125 volt 20 amp plug on the end, which are exceedingly common in my garage, which is great because I have no outlets to fit these. So that's coming off of there. But I do have in the house a nice brand new 240, I guess it'd be 250 volt there 20 amp 250 volt plug and an outlet, which means I can go over yonder, upgrade that outlet to the 20 amp, which of course, given that it's wired with 14 gauge wire, isn't really legitimate. But also given that it's on a wall I'm tearing out soon enough, I'm not worried about it, because I'm only ever plugging in my bandsaw and this monstrosity, and the breakers are still 15 amp breakers. So just a little plug swap, outlet swap. So I'm gonna go inside and get the bits and pieces to do that. I'll be right back. Alright, through the magic of time shifting and a dead camera battery, I have swapped the old 15 amp outlet out for a 20 amp, but it's a T-slot, so I can still plug in my bandsaw. But I feel like one of those birds that fakes injury, and I'll show you why in a second. Alright, here's why. I have no shortage of 20 amp, 250 volt accessories. Look at these weird cross-eyed looking things. Because I stocked up knowing that I didn't have what I needed for this project, but I thought I might have a 15 amp plug somewhere, and I still think I do. And that would have saved me having to rewire the outlet. But I couldn't find it. I got bored of looking, so I'm going this way. And I looked at this again. This ready-made. I could swap this out, but it's not long enough. I'd have to move my radial arm saw, which is just right there. And I don't want to, because it's heavy, and I don't want to. So instead, while the battery was recharging, I started work on this to make a real man's extension cord. That's right. At least a temporary one in the meantime. I just need to hunt down Chastity wherever she's hiding. There she is. Chastity. Because she's, they're strippers. Get it? Ha. Strip some wire. Let's clean the ends up of that. There we go. I'm not sure how long this needs to be. I think those are yellow. Yes, they are. That one's tight. Let's open this thing up a bit. Where are we in focus? There. If I can work about there. I love forgetting to put these things on. It doesn't matter too much in this situation, but I don't want any live wires exposed. Alright, this thing. So if I strip about that much off, that much should be good to go. This looks like this is 14 gauge. Green. Tighten that up. Ooh, that's nice. Oop. That's 2 live wires. And the ground. These are nice screwdrivers. And for those of you from countries that don't have awesome screwdrivers, Robertson are color coded. See? Yellow, green, red. Most electrical stuff is green and red. Except these Leviton plugs have dropped it. 3 screws in the end that are focus that. There we go. They're yellow. Well, the screws aren't yellow. You know what I mean? Now this thing is keyed. One of my first jobs was working graveyard shifts, assembling lots of these Leviton plugs onto the ends of this stuff. It's all out of focus. Look at that. That's definitely not to code or anything. It's good enough for this project. Schematic. What's there? You just have to trust me. There it is, there it is, there it is. Schematic. Forgot it's on my website. So I'm just looking at go away. How much wire I'm gonna need and who goes what where. I'm trying to make sense of all the contacts on this drum switch, so it's a start, stop, run kind of dealio with some big old ugly contacts down there. Could do with some cleaning, but it's just a dry run or damp run, I guess. So I've got 6 screw terminals, and 3 of them have jumpers on them. Oh, there's labels. Look at that. 5, 10, 4, 6, L2. L2. I connect a wire to that. I guess I just piggyback on with that thing. Alright. An almost endless supply of pigtails. So I'll just plunk that on the floor like that. Get one of these things right here, and kind of peel that open just a bit. There we go. All I want is pliers. They're over here. Pliers. Now, I don't really care about the ground, so I'm going to use it as a ripcord. Just trying to take out the tripod. Whoop. We'll call it that for now. Wire cutters. Okay, there we go. Over there. Whew. Alright. Look at that. Lots of wire. L1 goes to the motor and to L1 inside this box. I'm coming off of this box over to yonder motor. Let's go with that. What have we got? Screw terminal? Yeah. Let's go on the right. 14. Screw terminal on this end. Oh, what we're gonna do there? Can't see it, but it's there's an eyelet. And originally, they'd use these shenanigans, screws and brass screws and a nut and bolt, hold it all together. So I'm gonna have to think about that one a bit. Really, connection. Phone keeps locking. Paper would be much nicer. L1. You know, probably gonna do a splice in here and power. L1, L2 goes straight to the controller. Yeah, I'm gonna bring the power into the motor, because on the motor, let's just creep this up. There we go. The motor has an electrical box. There's a room inside it. That wasn't an accident. I didn't make that long enough for that screw terminal. Oh, yes. These are lovely. This is a sketchy arrangement. Just whoop. Anyway, that gives me enough to get inside here, so I can get these things. What's going on here? Let's see if I can work through the camera. Turn of the century electrical things, as Canon sees it. I think I made that loop too big. Oh, I definitely did. Put that on there. Put that on there. Gee, a nut driver would be handy about now. Oh, there's one wire connected. Well, the battery's just about dead again. I didn't give it long enough to charge, so I'm gonna put these wires on here, and that'll probably be it for tonight anyway. Since we last visited, which was about 45 minutes ago, I had a delicious dinner, courtesy of my wife. The camera is charged, and I finished bodging together some wires. I also procured myself an analog copy of the schematic, which I should verify. Oh, and exciting, a Duracell 9-volt battery, which I will be putting in this ever so fancy Mastercraft, look at over there, multimeter. Ah, we've got power. Maybe I should, oh, there we go. That was too high of a range. 1.5 ohms. Alright. 1.5. Oh, I don't have a calculator. Sounds right. Let's go with it. I'm going to reassemble this. So just tighten up that. Now, the way the start mode works is it basically sets this, I think, to, by default, position 6. So it sets it to a fairly high speed. I'm guessing so there's enough torque to get the motor started. And then when you're on run, it drops back to whatever you have it set at. So if you're on 6 already and you start it and run it, it'll run at the same speed. And then, anyway. So that's looking good. I'm going to do an eyeball inspection, tape up these leads, and I'll be right back. So I double checked all my connections, everything looks good. Screwed the old starter switch to the table. There's a good reason for that, but I forgot one thing. I didn't check for continuity to ground from the motor. So I've already, I also taped these up and affixed them with a zip tie to the side of the motor, which means I just have to jam this inside the wire nut here. I'll pop the wire nut off and check. Ground, of course, in this situation. That is an open circuit. That's good. I'll check from the other lead just to be sure. Need to pop the lid off of this thing. The motor is connected to 4, which I think is that one. Alright, from that to there. Open circuit. So that's a good sign. This equipment was, of course, designed before grounding was, I guess, a significant consideration. So there's no bonding posts anywhere, no bonding terminals. So I could add some. I've added one. I put this box on here, so that has one now because the box has one. I think I can wind the screw all the way without it jamming into things. This, I should probably add one. It'll be grounded to the frame of the press. So there we go. So now I can plug it in. Alright. There we go. Do the old smoke test. Turn the breaker on. Hasn't turned off. Can't see the camera. Now I can. That's a good sign. Alright, so now I'm going to put this on AC voltage detection. The ground is connected so I can check. See, that's not good. There's 111 volts to ground off the frame of the motor. What is that coming from? Well, it's a good thing I checked that. That would have been a surprise. I'm no expert on AC, so weird things can happen with inductive and capacitive coupling. So what I'm going to do is craft me some grounds. There's one. We'll hook that around the screw. I'm just going to back off one of these screws. I've got my other ground terminal like that. Very nice. Tighten that up. What have we got here? Not quite as many options. I see one. That's not really. Like up here. Look at that. I have to. Oh, it's grounded. Okay. Gotta touch it. Okay, turn the breaker back on. Well, that didn't trip, so that's a good sign. I think there was just a bit of leakage off the ground to the motor. No voltage, so there's something leaking through. This case is grounded, so I can go from that to that. Nada. Okay, so I flip this to start. Well, that isn't cool. Bearings sound like crap. So there's the switch is two position, as I mentioned yesterday. There's start, which starts it at setting 5, and then there's run, which runs at full speed. Takes a bit, so that's at the lowest speed setting. That's the bearings. I think they're a bit dry. So that's on setting 1. Now if I try on start, which about the same, and then switch to run, C spot run. Now if I do this without electrocuting myself, whoop, there's full speed. Start. Here at the speed. There's full speed. Really like that sound. So I need to take care of that. Anyway, that works. One other thing I wanted to check while I'm out here is if my thoughts, my theories on the screw being live, yeah, we're definitely right. So that's good design, Cutler hammer. Anyway, it's kind of fun to watch.